Hey everyone, and welcome back to the channel. Today, we're diving into a topic that sounds like it's been ripped straight from a science fiction movie, but I assure you, it's very, very real. We're talking about a fundamental shift in the cybersecurity landscape. A new era where malware isn't just written by humans, but generated by artificial intelligence. We're talking about VoidLink. This isn't your average script kiddie malware. This is a sophisticated cloud-native Linux framework that was created in large part by an AI. And the most chilling part, it was built by what appears to be a single developer in less than a week. This changes things permanently. So today we're going to break down exactly what VoidLink is, how it was created, what makes it so dangerous, what this means for the future of Linux security, and most importantly, what you can do to protect yourself. This is going to be a deep dive, so grab a coffee, settle in, and let's get into it. So, where did this all begin? In late 2025, researchers at Check Point stumbled upon a cluster of unusual Linux malware samples. Now, Check Point is one of the leading cybersecurity firms in the world. They've seen it all. But when they first encountered VoidLink, something was immediately different. They were struck by its maturity. This wasn't some clumsy, cobbled-together code written by an amateur. It was efficient, highly functional, and built on a flexible, dynamic architecture that showed signs of professional-grade engineering. Right out of the gate, VoidLink was using advanced techniques that most malware developers wouldn't even attempt. We're talking about eBPF, which stands for Extended Berkeley Packet Filter, and LKM Rootkits, which stands for Loadable Kernel Module Rootkits. Now, if those terms sound intimidating, that's because they are. These are not beginner-level tools. Let me break this down for you. eBPF allows programs to run inside the Linux kernel without changing kernel source code or loading kernel modules. It's incredibly powerful and incredibly dangerous in the wrong hands. LKM rootkits, on the other hand, allow malware to load itself directly into the kernel, giving it the highest level of system access possible. This means the malware can hide its processes, files, and network connections from almost any detection tool. It's like having a ghost in your machine. The malware was clearly designed for post-exploitation in modern cloud and container environments, specifically targeting platforms like Kubernetes. And if you're not familiar with Kubernetes, it's essentially the backbone of modern cloud infrastructure. Companies like Google, Amazon, Netflix, and thousands of others rely on it to run their applications at scale. So when malware targets Kubernetes, it's going after some of the most critical infrastructure on the planet. What really raised eyebrows at Check Point was how quickly VoidLink evolved. They watched in near real time as this malware transformed from a functional, but still developing, build into a comprehensive, modular, and fully operational platform. New components were being added. The command and control infrastructure was being established. It was accelerating toward a full-fledged operational platform right before their eyes. This kind of rapid development usually requires a well-funded, coordinated team of developers working around the clock, not a single actor working alone. But as we'll see, that's exactly what happened here. And that's where the story takes a turn. The creator of VoidLink, while clearly brilliant, got sloppy. Every so often, even the most advanced threat actors make mistakes. And the VoidLink developer made a few critical ones. They left behind a trail of digital breadcrumbs. Through a series of operational security, or OPSEC, failures, the developer exposed huge portions of VoidLink's internal materials. We're talking about the crown jewels, the documentation, the source code, and even the project components. This is like a bank robber leaving their blueprints, tools, and getaway plan at the crime scene. But here's the bombshell. The leaks also contained detailed planning artifacts, things like sprints, design ideas, and timelines for 3 distinct internal teams. At face value, it looked like a well-resourced organization with a development plan spanning more than 30 weeks. It suggested a major investment in engineering and operationalization, but the evidence pointed to something else entirely. These planning documents, written in Chinese, had all the hallmarks of being generated by a large language model, or LLM. They were highly structured, consistently formatted, and exceptionally detailed in a way that only AI-generated content tends to be. It became clear that these weren't 3 teams of human developers. It was one developer, orchestrating an AI to do the work of an entire team. The tool they used? An AI assistant called TRAE SOLO, embedded in an AI-centric integrated development environment, or IDE, named TRAE. Now, for those not familiar, an IDE is basically a software application that provides comprehensive facilities to programmers for software development. Think of it as Microsoft Word, but for writing code instead of documents. Here's how the process worked. The developer would provide general guidelines and an existing code base as a starting point. The AI service would then translate those guidelines into a detailed architecture and construct a development development plan across 3 separate simulated teams, complete with detailed coding guidelines and constraints. Then, the AI would execute the implementation. And here's the kicker. The first functional implant was created in under a week. Let that sink in for a moment. A sophisticated kernel-level malware framework from concept to functional code in less than 7 days, something that would have taken a team of skilled developers months to create, was done by one person with AI assistance in a matter of days. Check Point researchers noted something particularly interesting. The opening directive to the AI wasn't to build VoidLink directly. Instead, it was to design the malware around a thin skeleton and produce a concrete execution plan to turn it into a working platform. It's unclear whether this approach was purely pragmatic, intended to make the process more efficient, or if it was a deliberate jailbreak strategy to navigate the AI's safety guardrails early and enable full end-to-end malware development later. Either way, it worked, and it worked frighteningly well. So, what makes VoidLink more than just a novelty? What makes it a genuine threat that should concern every Linux user, especially those running systems in the cloud? It's a convergence of several dangerous capabilities. Let's break them down one by one. First, as we mentioned, it's cloud native. This isn't malware designed to infect your grandma's Windows laptop. It's designed from the ground up to attack modern infrastructure. The cloud servers, the containers, the Kubernetes, clusters that power so much of the internet. This is where the most valuable data lives. Financial records, healthcare information, intellectual property, trade secrets. And VoidLink is built to thrive in these environments. It understands how cloud systems work. It knows how to move laterally between containers. It can enumerate cloud resources and identify high-value targets. This isn't just an infection, it's an intelligence gathering operation. Second, it's adaptive evasion. This is where it gets really clever and frankly terrifying. Research from Sysdig, another leading cybersecurity firm, revealed that VoidLink doesn't just try to hide. It actively profiles the system it's on, looking for signs of security software. It scans for processes and installation paths of over a dozen major security products. We're talking about CrowdStrike, which is one of the most widely deployed enterprise security solutions, SentinelOne, another major player, Carbon Black, Falco, Sysdig itself, Wazoo, OSEC, Oscary, Audit, ClamorV, even Alibaba's Aegis security system. If VoidLink finds one of these tools, it doesn't panic, it doesn't shut down. It changes its behavior to avoid detection. It's like a chameleon, changing its colors to blend in with its surroundings. It even checks if it's being analyzed by dynamic analysis tools like Frida or being traced by a debugger like GDB or Strace. This isn't just stealthy, this is actively anti-forensic. It's designed to evade not just detection, but also analysis. Even if a security researcher gets their hands on a sample, VoidLink can detect that it's being analyzed and change its behavior accordingly. This makes reverse engineering and understanding the malware significantly more difficult. Third, and this is a big one, is Serverside Rootkit Compilation. This is the first time this technique has been documented in the wild, and it's a game changer. Traditionally, kernel-level rootkits have a portability problem. The Linux kernel is constantly being updated. Different distributions use different kernel versions. A rootkit compiled for Linux kernel version 5.15 won't work on version 6.1. This has always been a limiting factor for attackers. They either had to compile rootkits for dozens of different kernel versions and hope they had the right one, or they had to compromise a system, check the kernel version, compile a rootkit for that specific version, and then deploy it. Both approaches are time-consuming and risky. VoidLink solves this problem completely. Its command and control, or C2, server builds the kernel module on demand for each specific target. Here's how it works. The malware infects a machine. It reports the kernel version, along with other system information, back to the C2 server. The C2 server then compiles a perfectly tailored rootkit just for that machine and sends it back. The malware loads the custom rootkit into the kernel, and boom, you've got kernel-level persistence that's perfectly matched to the target system. This makes VoidLink incredibly versatile and scalable. It can target any Linux system, regardless of kernel version, distribution, or configuration. It's like having a master key that can open any lock. Now let's get a bit more technical. I want to walk you through how VoidLink actually operates once it's on a system. This will help you understand not just what it does, but how it does it and why it's so difficult to detect and remove. VoidLink uses a multi-stage loader architecture. This is a common technique in advanced malware. Instead of deploying everything at once, which would be noisy and easy to detect, it deploys in stages. Each stage is small, focused, and designed to evade detection while preparing the system for the next stage. Stage 1 is typically a small dropper or initial payload. This might come in through a compromised container image, a vulnerable web application, or even a supply chain attack. Once it's on the system, it performs reconnaissance, it checks the kernel version, it looks for security products, it profiles the environment, then it phones home to the C2 server with all this information. Stage 2 is where the custom rootkit comes in. Based on the reconnaissance data, the C2 server compiles and sends back a kernel module specifically designed for that target. The malware loads this module into the kernel, giving it deep, persistent access to the system. Stage 3 is the deployment of modular plugins. VoidLink is designed as a framework, not a monolithic piece of malware. Depending on the attacker's objectives, different plugins can be deployed. There might be a plugin for data exfiltration, another for lateral movement within the network, another for maintaining persistence, another for credential harvesting. The modular design makes VoidLink incredibly flexible, and throughout all of this, VoidLink is constantly checking for security products and adjusting its behavior. If it detects that it's being monitored, it can go dormant. If it detects that it's being analyzed, it can self-destruct. It's designed for long-term persistence and espionage, not smash and grab operations. So what does this all mean? Why should you, as a Linux user, as a system administrator, as someone who cares about cybersecurity, be concerned about VoidLink? It's not just about this one piece of malware. It's about what it represents. VoidLink isn't just another piece of malware. It's a proof of concept for a new paradigm of threat creation. It demonstrates that a single skilled actor can now leverage AI to achieve the output of a well-funded state-sponsored group. Think about the implications of that for a moment. For years, we've categorized cyber threats based on the resources behind them. Script kiddies at the bottom, cybercriminal gangs in the middle, nation-state actors at the top. Each tier had different capabilities, different levels of sophistication, different resources. VoidLink blurs those lines. It dramatically lowers the barrier to entry for creating highly complex, sophisticated attacks. The speed, the scale, the sophistication, it's all amplified by AI. A lone developer can now create malware that rivals what nation-states were producing just a few years ago. Check Point themselves said it best, and I'm going to quote them here. While not a fully AI-orchestrated attack, VoidLink demonstrates that the long-awaited era of sophisticated AI-generated malware has likely begun. And that leads to a deeply unsettling question. The only reason we know VoidLink was AI-generated is because its creator made some OPSEC mistakes. We got a rare glimpse behind the curtain into the developer's environment. But how many other sophisticated malware frameworks are out there built using AI that left no artifacts to tell the tale? How many other VoidLinks are operating in the wild right now, and we just don't know about them because their creators were more careful? We just don't know. And that uncertainty is perhaps the most unsettling part of all. Alright, so we've talked about the threat, we've talked about how scary it is, but I don't want to leave you feeling helpless. There are things you can do to protect yourself and your systems. Let's talk about practical defense strategies. First and foremost, keep your systems updated. I know, you've heard this a million times, but it's more important than ever. VoidLink and malware, like it, often exploit known vulnerabilities to gain initial access. If you're running outdated software with known security flaws, you're making it easy for attackers. Enable automatic security updates where possible. Subscribe to security mailing lists for the distributions and software you use. When a critical security patch is released, apply it as soon as possible. Don't wait. Second, deploy and maintain proper security tools. Yes, VoidLink can evade many security products, but that doesn't mean you should give up on security tools altogether. The fact that VoidLink goes to such great lengths to evade detection tells you that these tools are effective when properly deployed. Use a combination of tools. Don't rely on just one. Endpoint detection and response, or EDR, solutions like CrowdStrike or SentinelOne. Runtime security tools like Falco or Sysdig for container environments. File integrity monitoring, log analysis, network monitoring, defense in depth is key. Third, monitor for anomalies. VoidLink is designed to be stealthy, but it's not invisible. It still has to communicate with its C2 server. It still has to perform actions on the system. Look for unusual network connections, especially to unexpected IP addresses or domains. Look for unusual process behavior. Look for unexpected kernel modules being loaded. Set up alerts for suspicious activity. Use tools like Audit to log kernel level events. Use Oscary to query your systems for indicators of compromise. The more visibility you have into what's happening on your systems, the better your chances of detecting something malicious. Fourth, implement zero trust architecture. The old model of security was castle and moat. You had a hard perimeter, and once you were inside, you were trusted. That doesn't work anymore. VoidLink is designed to operate inside your network, moving laterally between systems. Zero trust means you don't trust anything by default. Every user, every device, every application has to prove it's legitimate before it gets access. Implement strong authentication. Use microsegmentation to limit lateral movement. Enforce least privilege access. make it as hard as possible for malware to spread, even if it does get in. Fifth, educate your team. The human element is often the weakest link in security. Make sure everyone on your team understands the threats you face. Train them to recognize phishing attempts. Train them to follow security best practices. Create a culture where security is everyone's responsibility, not just the IT department's. VoidLink is a wake-up call. The threat landscape is evolving at an unprecedented rate, and AI is now a force multiplier for both defenders and attackers. As defenders, we have to respond in kind. We need AI-enhanced security solutions that can keep pace with these new AI-generated threats. For those of us running Linux systems, especially in the cloud, the message is clear. The days of assuming a level of obscurity are long gone. Linux is no longer a niche operating system that flies under the radar. It powers the cloud, it powers the internet, it powers critical infrastructure. We are high-value targets, and the tools being built to attack us are more advanced than ever. But here's the thing, we're not helpless. We have powerful tools at our disposal. We have knowledge, we have community, and now we have awareness of this new threat. Knowledge is power, and by understanding how VoidLink works, we're better equipped to defend against it and threats like it. This is a developing story, and you can be sure we'll be tracking it closely. As more information comes out about VoidLink and other AI-generated malware, I'll be here to break it down for you. What are your thoughts on AI-generated malware? Does this change how you think about Linux security? Let me know down in the comments. I read every single one, and I love hearing your perspectives. As always, thank you for watching. If you found this video informative, please give it a thumbs up. It really helps the algorithm show this content to more people who need to see it. Subscribe for more deep dives into the world of Linux and cybersecurity, and ring that bell so you don't miss the next episode. Stay vigilant, stay informed, and most importantly, stay safe out there. I'll see you in the next one.